All right, we are live. This is Sesame Street, brought to you by the letters H, B, and O. Whoops, wrong broadcast. All right, now it's Hangops. We're back. It is August 14th, 2015, and the topic in theory today is Google Cloud and the Google Compute Engine, which is their pretty cool virtual machine as a service offering. We've got special guest Ken White joining us today. Ken, you want to give yourself a little intro? Say hi. Uh-oh, we lost Ken. Okay. Hangouts. Maybe it's just me now. All right, well, we'll have to wait for him to rejoin. It's just going to be my smiling face. Is this thing on? Need one of those technical difficulties signs, like on television. Oh. Okay. Well, hi, Mom. I don't know. Awkward. You. Oh, that's a light bulb. Or not a light bulb, but a light. Okay. Looks like Ken is still alive. He's working to get himself back on here.
Yay for technology.
We rebuilt you.
Sorry,
Bigger,
I don't know
faster, stronger.
Right.
It was just
Sorry
me.
about that.
That's okay. So say hi. Tell us who you are.
Hey guys, I'm Ken White. I work with a couple different organizations, but one that's we've been doing quite a bit of work with GCE is sort of in the healthcare and public health space. We have a technology stack that runs Java, Tomcat, kind of on a Linux, Red Hat family base. And there's some kind of unique things in our area, which is kind of around regulatory. So a lot of issues around identity management, access, auditing, heavy, heavy security, disk encryption. Yeah, we've got probably 70, 80 systems in production systems in different customer deployments. Maybe a third of that is DigitalOcean, but increasingly more on the GCE side. And really the only thing holding us back from sort of expanding is kind of an analog of RDS, of Postgres RDS. It's a huge benefit and service for for our particular use case. The ecosystem at GCE is growing, obviously, but that's one piece that's kind of holding us back. But yeah, in terms of the performance, I mean, it's solid. The network reliability is right up there. So we've been pretty happy with things so far.
Okay, cool. So I know you have a pretty big background in security stuff, but is
I
is
did.
is systems administration, running production systems also like been a part of your kind of like
Yeah, it's
day-to-day life?
yeah, no, it's been a key part. So I did quite a bit of work for several years in the trial space. So new therapeutics being developed for uh, oncology, for heart disease, for lots of different um, conditions. And some of those trials were 7, 8 years into sort of development, and $200-300 million drug in process. So there's a huge amount of compliance things around that. But yeah, I was CTO and owned global operations for, I guess, the second or third largest core laboratory in the world that does clinical research. So um, I was the sort of architect and system lead for 2,000 clinical systems in the world. So it was spent many years doing that, and yeah, I've kind of inherited um, network ops and security ops for the last couple of projects that I'm involved with.
Okay, so it sounds like then you have a pretty extensive background with like probably traditional data center deployment stuff, and then you've done a fair bit with AWS over the years, right?
Yeah, and actually, we were one of the first groups with FDA to really push on public cloud. So we had some fairly I'd say safety critical systems on AS as far back as 2009, and so that took quite a bit of work to sort of talk to regulators and talk to people who are you know at that time used to a very different role in terms of security and controls and auditing and things. And so now you look at every major pharma company, clinical research organization, they're running major production systems on Amazon. And so, but yeah, we did a few things around disaster recovery that were sort of weird. Like they were like fixated on tapes and on sort of the classic things. And so by demonstrating truly high availability systems that we weren't just sort of you know praying that one core switch didn't go down, or that one rack in the data center was sufficient, then eventually we sort of won that argument over. But yeah, so over the last 10, 15 years, I've had my hands in kernel development, uh, network architecture, and crypto. So a lot of different hats I've worn.
Cool. And so, what what sort of brought in your current focus brought your organization to look at GCE, and what's been your experience so far, and what are some of the things that make it unique? Because I've been ramping up on it recently, and I'm definitely uh, seeing, I think some of the things that make Google unique and some of their approaches to infrastructure,
Right.
you know, within sort of how GCE works, and some of its design. Sort of curious what
Right.
your,
Well,
yeah.
yeah, no. So honestly, the original motivation was just um, sort of pushing your agnostic. You know, it's not like Amazon goes down, right? But from a lot of client or auditors' perspectives, they'll see one high-profile report about some outage in one availability zone, 2, 3 years ago, the Dublin Center, with lightning, and they're like, you know, it's funny because the scrutiny that people put on public cloud, if they had the media turned on their own data centers and they had thousands of sort of monitoring ops 24/7, then I think people's perspective might change. But yeah, I mean the whole notion that there's not scheduled downtime is kind of anathema to a lot of auditors and regulators. But one of the things too that was really appealing to us is we actually just through dumb circumstance had access to the engineering and product team at GCE, and so they were able to sort of step us through quite a few things on HIPAA and some of the stuff we had to do with the federal clients, which was hugely helpful. I mean, I think gotten much better, but AWS definitely had had some challenges for a while in terms of sort of direct higher level engineering support. I mean, you could get it through sort of the normal open source channels, but if your instance was having a problem, or if there was some weird flaky BGP behavior on your segment of the network, it was trickier then. And I think GCE has, Google's got some learning to do on that side as well, but they've gotten much better in the last 6 months or so, in my opinion. Hey, Kelsey.
Hello.
Hey, yeah, welcome, Kelsey. We're glad you can make it. When you can introduce yourself, kind of let folks who may not know who you are.
Okay, cool. I'm Kelsey Hightower, currently working at CoreOS, wearing many hats. One of them currently is head of product. Also lead up the evangelism effort, so during the conference speaking, the keynotes, and I do a lot of stuff around the community workshops, so whether that's Golang or Kubernetes, just making sure people get a chance to learn this stuff. And I still write code quite a bit, so I'm always building tools, utilities, or contributing directly to Kubernetes when it makes sense.
Awesome. Welcome. So, kind of think through Twitter, learned that folks over at CoreOS, right, you run a fair number of your own production systems, and some of that stuff you are running on GCE. So, sort of love to hear more about that. What your experience has been. In particular, like what have you found that's unique about GCE that's maybe influenced the way you deploy things on it? Sort of, yeah.
Yeah, so for us, mainly, I think I was said earlier, we're looking for the common denominator between cloud providers, right? So I think we're trying to avoid the business of going all in on any particular cloud provider so you don't get stuck. I think for us, CoreOS as a platform, we need to dog food it in a way we want customers to dog food. So we've been talking to a lot of people, and I think it was said earlier, that are not afraid of Amazon going down per se, but they just want to make sure they can actually move between the environments. Whether the price gets cheaper or performance gets better, they want to have the option of dialing one up and dialing one down. So on the GCE front, some of the things we do like is what they did with networking. So before Amazon made it common knowledge, GCE came out of the gate with just the ability to program your gateway. So being able to add static routes to your cluster simplified tons of things for us. So we built a tool called Flannel to do overlay networking, and we saw those patterns kind of catch on with Weave, and there's other players in that game, and then some cloud providers, those are just absolute necessities if you want to route traffic between, let's say, Docker bridges between multiple hosts, where in GCE you can kind of skip all that by using the ability to program the router in your infrastructure. You can do that now in Amazon's VPC, but that's just like a highlight of Google day one. So we really like the networking model in Google. Also, it kind of got a little bit simpler for some reason. If you use Amazon quite a bit, there's tons of choices there between instance sizes, performant network or not, how do you get performance on the persistent disk layer. There's a lot of options. GCE just kind of made it really simple. Here's the instance types. You make disk bigger, you get more IOPS. Very straightforward. So for us, I think going into GCE, it just became very simple to get that common denominator across the cloud providers. Some gotchas, lacking SSL on the load balancer, that was kind of still a problem, I think, and they kind of came to the late on edge networking, meaning just getting the load balancer in a way like you would use ELB. Those are kind of some of the gotchas that we saw in GCE.
That's a great point, because even in my experience, even really seasoned engineers and sysadmins, when they first sort of start getting into performance on AWS, the whole notion of VPCs versus the traditional, the single root virtual IO, options, the HVM versus other types of visualization. I mean, a lot of that's lost. If the documentation's there, and if you dig far enough, you'll find it. But I think a lot of people are they're probably getting a fraction of the performance on AWS that they could. And I think you're exactly right. That GCE makes a lot of that easier. Just as you say, you want more performance. Here's more IOPS. So yeah, that's a big difference in the two.
I guess the last thing is the API. Oh my goodness. To me, the API is just fantastically well done in Amazon. And it's mainly from the situation of the way it's documented, the way the clients are built from a definition. So you can
Yeah.
actually look at the JSON spec, and that's how all the clients for every language are generated in GCE. So my early experience with GCE was writing the Packer integration for GCE maybe a year and a half ago. But their API is just still is really, really nice to work with, especially since they have this idea of an operation. So you do these things like spin up a VM or create a firewall rule. What you get back is an operation that you can check and be sure that it actually comes up. Whereas we found automating things in Amazon's world, things were returned, and maybe you got all the VMs you wanted, maybe you didn't get all the VMs you wanted. So you have to kind of do this reconciliation process, which is kind of nerve-wracking for people using things like CloudFormation, where 90% of it works, but one thing that's important doesn't work, and you have to tear the whole thing down. So that's kind of been a critical piece for us using GCE for a lot of our stuff.
Cool. Would either one of you be willing to take a crack at sort of like a top-down description of what GCE is and sort of the core concepts of it?
Yeah, I'll start a little bit. So I
Okay.
think honestly, Google is very good at containers, right? And even the VMs you have in GCE run inside of a container. So you get your own KVM instance inside of a Linux container. So that's how it's presented to you. So their tools at the very low level are designed to manage containers. And I think we saw that early on when App Engine was pretty much the only thing you could get, which kind of gave out the Google philosophy of represent your application in terms of a container, and we'll use our ultra good scheduling and replication systems to make sure that we can scale your app horizontally. So I think that was like way too restrictive for a lot of people, just like Heroku is restrictive for a lot of people. And then you saw the world of VMs come out. And I think that's why we saw things come out kind of slow, right? We saw the addition of here's a virtual machine and what a virtual machine is. They also have very limited images you could actually choose from. I think there was like one image very early on. So you never saw the maturity of like you see in Amazon where there's tons of people with images, you can share them and all these things. That just really isn't there on GCE because they have to play catch up. On one side, it's actually good because you're just not bombarded with choices, like 58 different CentOS images. They kind of have 5 or 6 official images or maybe 8, and you can share your private images with people. And I think lastly, I think Google is just really trying to give you the foundational infrastructure bits without hiding things in easy mode. I like to think Amazon does a lot to make things very easy for people that may see or maybe intimidated by infrastructure in some cases. And I think Google just gives you some very raw bits about networking, about a VM, and how to expect performance on their platform. So that's kind of where I see GCE, and they're starting to bring in more development-focused things, right? You see that with Firebase, you see that with the managed VM offering, and you see that with the whole GKE Kubernetes. You click that button, you kind of get this whole scheduler to your disposal, and you can just manage containers going forward. So I'll stop there and let other people add on to that.
No, I think that's great. I mean, one thing I'd say too is that I've noticed that the level of transparency when there is an issue or downtime is it's just it's very different than AWS. I don't have any infrastructure in Europe West right now, but I've gotten about, I don't know, 7 emails in the last 2 days because like 1% of some of the machines in their Europe West zone have been a little flaky with performance. I mean, on Amazon, the green check sometimes means green check, or sometimes means thousands of people are reporting problems, and it's just not caught up yet. So that said, when they, even after they broke out of, or I guess maybe this was just before beta, they would take entire DCs down for like 6 weeks, and so that really, it did force people to get religion about programmatic scale that they could bring up in other places. But there was a lot of gnashing of teeth when that first happened. You don't see that too often, where I don't think I've ever seen it, where an availability zone just goes, maybe they do some sort of rolling thing or something, but it's clear that there are people who have instances that have been running for years in some of the EC2 instances.
Yeah, definitely. Yeah, so kind of to to summarize, right? Like essentially, GCE is right Google Compute Engine. It's part of Google's platform, and it's providing you with Linux and Windows, fully virtualized virtual machines with sort of a network layer, so you can have private networks, and then you can poke, into those networks either through directly attached public IPs or through, like I said, there's a load balancing offering. They've got some VPN and peering and direct connect style networking options into their platform. You can do some routing. One of the things I thought was interesting is it seems like out of the gate they don't have as much of an emphasis on the idea of sort of like a NAT endpoint in the same way that sort of the VPC model that most people are familiar with is. So I thought it was kind of interesting
Also,
application.
the netting, I think, is kind of represented just kind of as your gateway, kind of like a
Yeah,
traditional router. So you basically just program that like you would any other router. So it's not really a dedicated instance like you see in the VPC. It's more part of their whole network fabric, right? So it's like, hey, here's how you get to the internet. Here's the two default rules that make it happen. If you want to do anything customized there, you can. Maybe you point your default gateway somewhere else, and you just kind of do that via your nodes. But they kind of do hide this idea that there's a instance running that's providing the gateway services, which always scared me in Amazon because I'm like, man, what if that NAT gateway thing like goes down?
yeah,
What am I responsible for?
yeah. Well, it's been interesting seeing the various uh, sort of scripts or architectures that people have built to sort of provide a highly available, default outbound route. And I think in some ways, some of the way that GCE, some of the defaults are, it sort of represents an assumption that you're building your infrastructure a little more like distributed and horizontally scalable. That's sort of like so there's it's interesting to see like what defaults are sort of code trying to steer you to certain architectures. But one of the things that I think is I've seen is unique about GCE, and I'm curious if either of you have used is the idea of the live migration scheduling option, the VMs, right? Being that essentially Google says, we may take host down for maintenance, and as part of that, we let you choose per VM sort of two guarantees. One is that we will live migrate your VM to another physical host, which will cause a brief period of performance degradation, or you can tell us that we will automatically terminate and restart that VM from scratch. Right, so those are sort of the two guarantees that they call like scheduling options. Have um, what what default do either of you tend to go with, and have you like seen the live migration in action or come to sort of rely on it in any way?
No, I definitely don't rely on it. I mean, the technology behind it is incredible, but it there's a couple issues. I mean, obviously, Google's got some of the best security people in the world, but it does sort of expose something that's pretty much true for any provider that's managing the hypervisor, which is they own everything in memory, right? So if you've got sensitive data, that data is being transferred, whether that's personal information, whether it's keys, whatever. That's always been true, but it's sort of just amplified when that happens, right? So I mean, it's a full memory snapshot of your running VM. Now we've made the decision to go with just terminating the instance. We've got enough replicas in just in our use case that it's it's easier deployment. I did see some early on stuff. I haven't looked at this recently, but there were under really really heavy load. I think it could be minutes sometimes. I don't know if that's still the case. To bring the new instances up.
Yeah, I kind of depend on live migration, thinking that maybe it's working underneath the covers. So far, maybe I trust that it's probably working for some things, but at CoreOS we just kind of design everything to fail. So I may click that button and kind of rely on it a little bit for etcd. But if anything did go wrong, I know I have replication and all of these things to take care of etcd cluster. But overall, we kind of like the idea that anything could die at any point. So everything has been built that way, especially our work that or the use of Kubernetes where nodes come and go, and then we have a scheduler that moves things around. So I think one thing I do like is this idea of those nodes that can be preempted. and that's pretty cool. So being able to get a cheaper price by saying, hey, look, when things heat up on GCE, these nodes are going to be reclaimed automatically, and but we'll give you a way cheaper price. So I think that's a great way to augment the whole idea of a reservation system. So instead of you trying to over subscribe, you just spin up those preemptive nodes when you can get them. And for the most part, they seem to work really well, especially as the load goes down in the evenings and special or in certain regions. So I think that's like a little unique thing, this idea that you can have a node will specifically be taken away from you at some point in time. I think that's pretty unique and awesome.
Yeah, no, that is nice. And it does sort of also underscore kind of the weird bizarre that is the reserved instance pricing with Amazon. It's there's it took us a long time to understand that that's a marketing thing. It's not a technical limitation. So we sort of had in our heads like, okay, well, these particular VMs we sort of own. They're ours, kind of, and then we'll have to sell those on the marketplace. And it's not really how it works. You eventually figure out that it's a rule of things. But yeah, the pricing for the reserved instance is a little goofy. But we do like that about GCE. That's for sure.
Yeah, so that's one of the big things that attracted our interest at Travis, the preemptible. Because our workload, right, the majority of it is these very short-lived jobs, and they can be very bursty. And so, what we've been playing with it for about a month. What we've done is we've had this sort of fully virtualized trusty beta that we've been sort of. It's been more of an alpha. We've been like poking at it a little bit and opening up a little bit, but moving it around, trying to figure out where we wanted to put it, because there's a fair number of people who they want a fully virtualized build environment that they want it dedicated and a new one every time, and then there's also a lot of people that want to be able to run Docker inside their build environment. So having a fully virtualized environment to run Docker and lets them do that. So as we looked around, two things that really attracted us to want to try GCE for this, and so we've moved our sort of beta onto it, is one is the billing model, right, which is a little bit unique in that the minimum is 10 minutes, right, for each instance, and then after that it's per minute, and that's for all instances, right, and then there's actually like the more you use it in a month, like it's 30%, I think, is the sustained, right, so it's actually like keeping it around for a while adds a little bit of a discount, but then when they added this preemptible model where the VM is good for at most 24 hours and may go away at any time, with like a 30 or 60-second warning, I can't remember off the top of my head, but with like a very brief warning that there's a service hook you can subscribe to, it's an additional 70% discount off the normal original instance rate. So that's where we've been running our trusty and Docker-enabled build betas for a couple of weeks now, is on there, and we've been having a great experience. We've been seeing really good boot times, and measuring stuff, and we are running all preemptible for all the build VMs, and I think it's pretty rare for us to have a Linux build that would run long enough to be killed. Our longer builds tend to be iOS or sometimes Android, but a lot of our OS 10 builds tend to be our longest ones. But yeah, and so we see that probably as the future for us as the foundation for the fully virtualized trusty and the Docker-enabled stuff and that we are working on. And so it's been it's been pretty interesting. We had some chats with them. It's interesting. They're sort of it's like. Basically, there's like 3 instance types. There's sort of like your normal core to memory one, and there's like a high CPU, so you get more cores but less memory, and then a high memory. So it's they still have like a matrix of things, but it's smaller. It's a smaller sort of like multi-dimensional matrix of what size computers do I want. And then, like you mentioned, Kelsey, the sort of the IOPS grow with the size of your persistent disks, right? Which they essentially have two models for disks for VMs. They have what they call persistent disk, which is sort of it's over the network. It's either SSD or spinning disk backed. And then they have local SSD, which is non-persistent, which is sort of the ephemeral to use for scratch space. So fairly simplistic there.
Yeah, I think the biggest point of this whole GCE thing is that it's providing, I think, true competition to Amazon. Like we saw it early on with the price drops, like that just benefited everyone. Like there is nothing wrong with Amazon, but GCE has like cut your Amazon bill considerably over the last year and a half, right? So I think whether you're a user of GCE or not, like you should just be happy it exists because they basically essentially gave you a discount on your Amazon services. And I like the fact that you have these two players experimenting with slightly different features because, and being, when I'm wearing my ops hat, I need those things to kind of compare because you can actually replicate some of those patterns on the other platform, right? Nothing's stopping you from going into chaos monkey mode yourself by saying, look, we're going to spin up some of our reserve instances and we're going to take them away from our internal clients as they use them because we want to give them to someone else. So just exposing that feature on GCE kind of gives people a nice way to replicate or think about replicating that feature on another cloud provider.
I agree, and I definitely see us as remaining cloud agnostic, right? I'm certainly no stranger to AWS, right? A community hero, and we, as far as Travis, we've built out a container-based infrastructure that a lot of people are using that we're really happy with, right? The builds are running in containers, and that's all running on EC2. It's auto scaling, and it just it hums along really well, and we see that as continuing there. We've built it on a nice set of the AWS services, and we're very happy with that. And but for workload like ours, which does have a lot of very short-lived instances, the smaller pricing window, right? That 10-minute chunk, and then by minute is too attractive not to run that workload there where we need fully virtualized and it makes sense to me. None of the major cloud providers really are doing nested virtualization. It makes sense to me why. Like why would they want you to stack VMs inside? They want you to just use raw instances, and that makes sense. But when it comes down to the sort of economy of scale for different size workloads, we definitely do look at that stuff. But I see us continuing to stay sort of cloud, multi-cloud, public cloud. In addition to, right, we have a private vSphere-based cloud for our OS 10 stuff with Mac Stadium, which if you read the OS 10 issue postmortem we published earlier this week, we had some details on that, and so, and which I think it's actually very healthy for us to do that and to run like different workloads in different clouds because it keeps us, experienced with them, and as we try to innovate our CI and CD platform, we need to be familiar with the offerings, and if we want to expand our integrations for like what we deploy to, like OpsWorks, in the future we like potentially integrating with like the container service or Google's container engine as like a build target or deployment target post build. It is in our best interest to have at least some of our workloads on some of the major clouds so that we can then know what we're integrating with and how people are likely to use it, because then we're already using it. So,
well, how deeply married are you all to the sort of the platform ecosystem at Amazon? I mean, is it painful to move, or have you kind of stayed mainly just look at the DNS and edge caching and VM sort of services?
Well, so all of our core like web service database stuff is actually on Heroku.
Okay.
We're big fan, big long-time user of Heroku. In fact, in the early days of Travis, when we just did Ruby builds, all the builds ran on Heroku too. And then there was a brief period, if you remember, where we did VirtualBox, and then some stuff moved to BlueBox, and so our pseudo-enabled precise stuff still runs on the OpenVZ-based platform, and it's the newer container-based builds that run in EC2, and that is it's fairly generic. We have a service that it's the same service that for all the cloud providers we use that handles the build lifecycle. So it instantiates the VM from an image, and then runs the build, and then at the end of the build cleans up. So that actually is a single service that we deploy onto, like, locally onto each cloud with the infrastructure. And then as far as the containers, they're just Ubuntu and Docker. They're fairly generic. We're a fairly like low-level consumer of all of our clouds in terms of, we get VMs, we get networking, but the fancier application like web service, database type stuff, we actually very heavily rely on Heroku for that.
So I have a question. As GCE gets better and all the other cloud providers, at what point do you start to see people abandon the data center that wouldn't traditionally abandon the data center? Like, what needs to happen? So GCE is making great progress. There's all this talk around non-volatile memory coming out soon. You'll start to have 512 gigs of RAM that will persist even on reboots on these machines. What do you think will take the cloud providers to get that change in mentality?
I mean, I think it really depends on the vertical, right? I mean, there's in the financial and the healthcare world, it tends to be very conservative, and also on some of the analytics. I mean, it depends where the data live, right? Because there's still physics, and if you've got hundreds of terabytes to crunch through, sometimes it is. But I think we're, at least in my view, we're seeing it in markets that would have been unthinkable 6 or 7 years ago. But there is there is an entire industry that's working really hard to keep the old guard busy, for sure.
I think Amazon has made significant strides to make moving enterprises into the cloud possible with the ability to extend their virtual private cloud through mechanisms like Direct Connect, so that it's very efficient to run workloads outside of the cloud and data centers, and then integrate those workloads with VPCs in the cloud. We've done that at an enterprise scale. Recently, myself and my team moving 100 plus servers into AWS, and they allow you to do all kinds of segregation of your workloads across accounts and across virtual private clouds, and determining which ones connect to which parts of your larger network. And so their networking story is pretty solid, where you don't even have to come in through the internet to access the resources. It just connects to our private network. And so that's been a pretty big sell. And then in healthcare, which I'm also working in, there are HIPAA eligible services in AWS, and those are progressively improving. And when you're in enterprises, you're set up with the right contracts with AWS, you get to work with their principal security architect and their solution architects, and they come in and they work through your designs with you, and you're able to kind of build out with their expert guidance on how to use their services. So I think they're definitely making big strides to bring people to the cloud in enterprises that may have more traditionally said that it was for security reasons or networking reasons or both. We're not gonna move to the cloud yet, or it's still being considered. Where now they're doing it, or they're planning to do it.
I think one of the biggest barriers for a lot of sort of, when you say more like traditional enterprise or data center architected services, where a lot of investment was maybe made in redundant networking and SANs and potentially like a large VMware infrastructure to use things like VMware's HA and DRS scheduling to provide sort of highly available like underpinnings that were transparent to like the host OS as sort of like a safety net. I think it's those kind of workloads that are going to be the ones that have the most like sort of friction, like drag to get them in there. But I think otherwise, in general, folks are moving what they can as sort of as much as they feasibly can around budget, and especially I think I think there's a pretty cool I'll say word like revolution, but there's a nice set of new like primitives being built now with technologies like CoreOS, Kubernetes, some of Docker's tool chain, Mesos, and all the things around it, right? And then you're seeing a bunch of container stuff come out of Microsoft to where, uh, there's a new sort of, we think of it as like a container, right? It's sort of a new level of packaging. I mean, obviously, there's a lot of history behind that, but there's a emphasis right now, like an awareness growing on like this sort of you package it as like this container, as this artifact that it's not as big as a VM, but it's not as small as like an exe or a war or something, right? It's like big enough to really encapsulate an application or even a set of services, and then there's these infrastructure tooling packages that are coming out to make it sort of easy to deploy that and scale it and connect to services. And so I think that is actually going to accelerate a lot of cloud usage over the next probably like 3 to 5 years. Is that people won't necessarily have to buy into the whole sort of like 12-factor style of application deployment that a lot of the more early things that we were calling PaaS sort of required. But they also won't have to build on the primitives of like EC2 and S3 and EBS and a VPC themselves. There's sort of this middle ground that I think that is being fleshed out really well, and is going to let a lot of people sort of move in because they can that middle layer of constraints and concerns they can then worry about is going to help a lot, I think, for a lot of workloads.
There's another factor too, which I'm sure there are going to be some skeptics when I say this, but the federal government's doing some interesting things that I think people haven't quite realized the impact. So one, for example, if people know this agency called 18F, or the Digital Services Group. They're doing some incredible things across the federal space, but they've come out with a couple of major awards where these were large companies bidding for some of these projects and things that straight out said you have to deploy on containers for this for this contract. I mean, they specifically mentioned Docker and and other container technologies. I mean, that's a big deal. The other is on the sort of security side. There is no federal standard for really high security things on the cloud. So it's in the federal world, there's what's called FISMA compliance or FISMA compatibility for sensitive workloads. Well, there's a low and moderate, but there's never been a FISMA high. And I think in January, so a draft came out for that. That's going to be huge because when workloads are able to have some of the most sensitive agency data running in public cloud, I think you're going to see a lot of things follow from that. But a lot of positive indicators for sure.
Another enabler, I think, is along the lines of what Brandon said, that the moving to something that allows for containerizing applications in the enterprise, where you're no longer depending on the hardware high availability capabilities, and instead are thinking of clouds of services even in the enterprise before you move into the cloud, is the right position for even people that are running VMware in their enterprises can move into before moving into the cloud, to kind of make that transition easier and enable it. I see that happening. I do. I think that that's a good story for the migration to the cloud as a whole.
Yeah, it'd be interesting to see if there's any stories out there of, particularly folks that are doing more like Windows workloads that have been successful in moving to GCE just based on like the live migration, sort of having a similar guarantee to like that VMware HA that so many businesses have come to just rely on. It's such a there's the reality is in a lot of places there's so many things that it's like, well, it's this one ASP.NET service that runs on this one SQL server, and like but it's critical, or or like a lot of the world is still like learning about what we think of as like basic distributed web app stuff, and so that
A lot of the
influence, that influences how much of the public stuff they can use, just because there's different failure domains and failure tolerances required. I when I was in Mozilla and we were first starting to use EC2 stuff, we had a fairly significant VMware NetApp infrastructure. Folks were like, "Where's my virtual console?" Perfectly reasonable question if your background is, even if you use just KVM, right? Like where's the VNC? Well, there isn't one. Well, what do I do if it doesn't boot? Well, you try again. It's just like what? And so it's it's yeah. It's easy to forget that stuff, but I think I actually really do think this sort of call it like the containerization stuff is actually gonna make a big difference.
I think the container thing is the proper abstraction for this services-based model, right? So what you're paying the cloud provider is a fee for CPU, memory, and other resources on their platform, right? And them punting back to you that you still have to manage the machine, which I think just was great at the time, that you just had to deal with the server, users, and all those things, but that's not really what you cared about, right? If you outsource your compute, you basically don't want to deal with it. Like, I do not want to go and set up the machine. Now, there's some cases where you might for specific things, but what you wanted to do is just say, look, here's my workload, and here's what it requires, and could you give me billing based on what I actually use? What we're forced to do right now is we're forced to buy a box way too big. Like, I grab a 1 gig VM and I put an app in that uses 256 megs of RAM. Too bad, you've lost 75% of what you paid for, and we're not going to refund that back to you because it's an allocation that we can't give to someone else. So I think the container, if we get to container-based pricing, I think a lot of people feel that that's a better contract. Here's my app in its entirety. The configuration that we see in containers, like what Docker kind of brought to the forefront of how to run my container, right? It binds to these ports. I want these CPU limitations because I just don't want to pay for infinite amounts of money. And we may have to have another definition that says what I would like to connect to, right? That's yet undefined. But once we have that, I think that's just a much better contract for what people want going forward, as long as we have the ability to put whatever we want in that container. That was the restriction on Heroku. You couldn't just do anything, right? Certain libraries you couldn't bind to, you couldn't touch the file system, you had to use environment variables for a lot of things. Application containers loosen up that restriction a little bit and make you feel like you have a bit more control that works in your environment and the provider's environment.
Definitely, and I think we're seeing this explosion of these different toolkits for how you actually, like, even if you're going to run like your base OS, you're gonna buy like the raw VM. You're gonna rent the raw VM from the cloud provider and run an OS in it. These very slim distributions. CoreOS is one example. You're seeing the higher levels, like scheduling and resource management things, Kubernetes, Mesos, and then you're seeing a lot of like local tools for, and so it's like there's this whole spectrum of innovation happening from like I want to run containers locally to maybe I just want to run a few of them on like a DigitalOcean VPS to I want to have basic scheduling in a private cloud, or like I want to use a public cloud but have my own sort of like data center level style scheduling thing of like Mesos and Aurora and Kronos and Kubernetes, and like you can like mix and match. And I think that's the really cool thing that over the next year or two, like right now there's the beginning of so many options, and because at the end of the day everybody's requirements are different, but I do think you said this abstraction sort of like an application container, we'll call it, is actually going to accelerate adoption for a lot of people, because they won't have to be like, oh man, I'm going to have to rebuild my data center in the cloud to use the cloud. It's sort of like they'll be able to just like abandon worrying about the data center concerns for a lot of their workloads. Maybe they'll still build their database, or maybe they'll want to customize Hadoop, and so they will do RAID 10s of giant EBS SSDs and something like that.
But what you're hitting on here is basically like the control plane for managing workloads, like ECS's control plane or Kubernetes control plane. In that case, what you want from the cloud provider is like, look, give me that instance, but all I want from it is its resources, whether it's disk, its CPU, its memory. But maybe in my data center, the control plane will live, where I give it instructions on what to deploy where. So we start aggregating these cloud providers just for specific resources. So just give me compute, CPU, and disk, and my control plane will manage the workloads. And this is slightly different than what we did with configuration management, right? CM tools, we did a lot of heavy lifting on redundant components that just weren't required when all you want are resources, and you have a scheduler and an agent that will take care of moving these workloads around.
Yeah, I think there's, I think when we look back in a few years and we'll say, well, wow, we were running, these VMs with 200,000 files and 150 processes versus, a couple hundred K and like 3. It's just a very different perspective. But I do think there's still some work on on namespaces and the sandbox. Right? I mean, sort of everything runs its root and then monolithic, control on the Docker side. I think there's a lot that we still haven't sort of figured out yet, and so I think it's a trade-off of risks. But I think there is some work to do there that's holding things back a little bit, in my opinion.
Definitely, and I think like in sort of closing, it's been about an hour. We'll wrap up. Coming from a heavy data center background, but also having been a big fan of a lot of what cloud type services bring, especially into like what I think of as a lot of the chores of maintaining a data center are now behind APIs for you. I do think the direct connect style stuff is also a really big win because it lets you, like the fact is, building data centers is a very capital intensive thing, and that is a real investment for a lot of companies, and it's not just even a sunk cost fallacy. It makes a lot of sense, and so I think it's really cool that it's it's becoming easier and easier to have it not be in all one or all the other, but still also like have like maybe you have security, you want fiber connections and that kind of stuff. You want to be able to like extend your data center into a publicly hosted but private style sort of cloud. So I think like at the end of the day, the more folks can use it in a way that makes sense to them is sort of where we win. Even like Travis, our approach to the CM market is it's not like the way we look at it is it's all the folks that are selling CI against the people who don't see why they need CI yet. And I think it's a similar thing, with as more as operators and vendors with the cloud. It's like, and any way that people can use it and it enables their organization is really where the win happens. Cool. Any closing thoughts, anyone? Any shout-outs anyone wants to give before we wrap up?
Oh, no, well, thanks for inviting me. I think this is a timely discussion, and I just want to remind people that I don't think this is a lot of people frame these conversations in GCE or Amazon. I think most people are going to see discussions around right? AWS and GCE, AWS and DigitalOcean. And the reason why we just need that to be the case so we can actually build tools that don't assume too much about one locality or the cloud provider you choose. And I think we're going to see better tools as a result. And I think Kubernetes kind of has that model. Mesosphere has that model. So that's kind of what I want to see go forward. This continued discussion around will make it just much better for everyone.
Yeah, I would definitely second that. And it's pretty cool to sort of be exploring another cloud provider and seeing the differences and comparing and contrasting, because I think even for me you see a different style of like design. You start to think like, here's another way to build your distributed systems. Here's a different set of primitives to build them on, and what does that mean? So it's good to stretch the brain. Cool. All right. Well, thank you so much, Ken and Kelsey, for your time, and we'll wrap it up here and see you next week.
Later.
Thanks.
Bye.